Okay, so now we're going to look at example number 4. The limit as x approaches 4 of g of x plus 3e to the 2x minus 8 divided by 4 minus x. If I look at the bottom, 4 minus x, if I plug in 4, it's going to go to 0. G of x at 4 for x is negative 3. 2 times 4 minus 8 is 0, so 3 times e to the 0 power is 3, so negative 3 minus 3 is going to be 0. So the limit as x approaches 4 of g of x plus 3 e to the 2x minus 8, that is going to equal negative 3 plus 3 e to the 2 times 4 minus 8, which equals 0. The limit as x approaches 4 of 4 minus x is equal to 4 minus 4, which equals 0. So the limit as x approaches 4 of g of x plus 3e to the 2x minus 8 divided by 4 minus x is going to be equal to, by L'Hopital's rule, the limit as x approaches 4 of g prime of x times 3e to the 2x minus 8. Well, e to the 2x minus 8 is going to be a part of it. The derivative of 2x is 2. So 6e to the 2x minus 8 divided by negative 1. So the fact that negative 1 is in the denominator, we know that it's for sure not going to be going to 0 over 0. So we have g prime of 4 plus 6e to the 2 times 4 minus 8 divided by negative 1. G prime of 4 is negative 1. E to the 2 times 4 minus 8 is e to the 0 power, so we're looking at 6 divided by negative 1. So 5 over negative 1, or negative 5. Okay, the limit as x approaches 0 of g prime of x minus 6 cosine of 4x divided by f of g of x. So we have the limit as x approaches 0 of g prime of x minus 6 cosine of 4x. So g prime of 0 minus 6 cosine times 4 times 0. Well, cosine of 0 is 1, so cosine times 1, or 6 times 1 is going to turn into our minus 6. G prime of 0 happens to be 6, which would make sense, and 6 minus 6 equals 0. The limit as x approaches 0 of f of g of x. So we are going to find g of 0 first. Whatever we get there is what we're going to plug into f of x. So g of 0 is 0. So now we look at f of 0, which is also 0. So by L'Hopital's rule, the limit as x approaches 0 of our original function, g prime of x minus 6 cosine of 4x divided by f of g of x equals the limit as x approaches 0 of the derivative of g prime is g double prime minus the derivative of cosine is negative sine, so we have 6 of them now, so negative or plus 6 times sine of 4x, but we also need to multiply by the 4x, so plus 24 sine of 4x. Derivative of f of g of x is chain rule, so f prime g of x times g prime of x. And we're going to go ahead and plug in 0 for all of it. So g double prime of 0, 24 sine of 0 divided by f prime of g of 0 times g prime of 0. Okay, well, 24 sine of 0 is 0. We know f prime, or we know g of 0 is 0. So the slope at 0 is that negative 1/2 again. So we need to figure out g double prime of 0 and g prime of 0. G prime of 0 is 6, g double prime of 0 is 2. So we get 2 divided by 6 times 1/2 is going to be 3, so negative 3, so negative 2/3. And our last one here, the limit as x approaches negative 2 of g of x plus x squared. So g of negative 2 plus negative 2 squared. G of negative 2 is negative 4. Negative 4 plus 4 is 0. The limit is negative 2, x approaches negative 2 of x squared plus 4x plus 4. Negative 2 squared is 4. 4 times negative 2 is 8. Plus 4 gives us 0. So by L'Hopital's rule, we have the limit as x approaches negative 2 of g of x plus x squared divided by x squared plus 4x plus 4 equals the limit as x approaches negative 2 of g prime of x plus 2x divided by 2x plus 4. So now we're going to go ahead and do this again. The one problem is that if I look at the denominator specifically, 2 times negative 2 is 4, negative 4, so negative 4 plus 4 is 0. So the denominator does go to 0. So we're going to look at these again, g prime of negative 2, and we're going to add negative 4 to it. So g prime of negative 2 is 4. So we're going to look at this separately again. So the limit as x approaches negative 2 of g prime of x plus 2x equals g prime of negative 2 plus 2 times negative 2. 4 minus 4 is equal to 0. The limit as x approaches negative 2 of 2x plus 4 equals 2 times negative 2 plus 4, which equals 0. So we now are going to take the last one we have. So by L'Hopital's rule, the limit as x approaches negative 2 of g prime of x plus 2x divided by 2x plus 4 is the same thing as the limit as x approaches negative 2 of g double prime of x plus 2 divided by 2. Well, g prime of negative 2, or g double prime of negative 2 is 3. So 3 plus 2 divided by 2. So 3 plus 2 is 5 divided by 2. So when we're doing this, the hardest part's going to be the notation of it. And then it's just kind of like picking out parts and pieces. It's deciding when we should write stuff down, when we shouldn't write stuff down. And that just comes with practice.